So, objectives. 1.1, describe the basic features of an algorithm. Explain how hardware and software collaborates. We're not going to do that. Give a free history of, you paid bucks for it. Give a brief history of computing, and then compose and run a simple Python program. I'm probably going to go off the rails as soon as we do this, and then I'm going to take us on our own adventure. But let's go ahead and look. So, computer science focuses on a broad set of interrelated ideas. Two of the most basic ones are algorithms and information processing. An algorithm is just a recipe. It's a series of steps. I could give you an algorithm for getting to Walmart. I could give you an algorithm for baking a Betty Crocker cake, right? It'd just say, look on the back of the box. But yeah, there in the back of the box is printed an algorithm. You know, there's an algorithm on your shampoo bottle. Wash, rinse, repeat. How many times are you supposed to repeat? I don't know. So anyway, an algorithm is just a series of steps to follow. The features of an algorithm, it consists of a finite number of instructions, right? And if some of the instructions would be repeated, you would specify that it's a loop, right? So you're on your way to Walmart. Am I at Walmart yet? No. Then drive another mile. Is there a stoplight that's red in front of me? No. Keep going, right? And, and it would keep looping until you get to the end. I'm going to stop using a Walmart example, and we're going to start doing, something more programmatic. So the individual instructions are so-called well-defined, meaning I'm not just going to say, calculate the answer, and then a miracle occurs. That's my favorite. But instead, we would specify the calculations or whatever is required in order to solve the problem, and then describe a process that eventually halts. So if it loops, it's not supposed to loop forever. That's called an infinite loop. And solve a general class of problems. Well, we're going to write one that solves a very specific problem. And then computers can be designed to run a small set of algorithms for performing specialized tasks. Why can they not run a large set of algorithms? I don't know. So information, commonly called data. I always say data. It's incorrect. In carrying out the instructions of the algorithm, the computing agent, the computer, manipulates information, the input. And then the input gets transformed according to well-defined rules. I type in the number of miles. That's my input. And then it gets transformed into something else, like if I want to know the number of feet in a mile. Well, there's a very specific formula for calculating that. And then producing output. Now that's kind of my algorithm, except I better specify what I am doing, what I am asking for, and what is supposed to be displayed, right? So this is not an algorithm yet. It's a general, kind of an outline, but we can go ahead and flesh it out, make it look like a real algorithm. So what I'm going to do is I'm going to write a program that, or not a program, but kind of describe, convert kilometers to furlongs. I'm not sure I pronounced that correctly. Spelled it correctly. That's the problem. Write a program that converts kilometers to furlongs. Furlongs being an old English unit, right? Furlongs. So that's not enough information. Hopefully I told you more. If I didn't tell you more, you'd have to figure out what you want to do. I might give you additional information, like write a program that asks the user for a number of furlongs and then converts and displays the equivalent number. Well, okay, I already goofed. I wanted to convert from kilometers to furlongs, so it should ask the user for a number of kilometers. And then converts and displays that to the equivalent number of furlongs. Now, I don't know the equation. I'm making this up as I go along. So here we go. Well, that's still not an algorithm. It's a problem specification. We need to come up with an algorithm. I'm going to write this algorithm in a very specific form known as pseudocode. So I'm going to put a start thing there. That doesn't mean anything. It's just where, kind of like the you are here on a map. Okay, the first step output how many kilometers. Now that's not a Python command. There's no Python command output. And then input kilometers. That's what the user is going to do. Now we're going to do our calculation. I'm going to go back and fill that. And then output the number of furlongs. Not done yet. So pseudocode is just an English description, right? Loosey-goosey English description. There are some rules to follow, but you know, this isn't a fundamentals of programming class. I'm not going to make y'all write a lot of pseudocode in it. But as a logic tool, you ought to be able to think in terms of breaking down your tasks like this. Even if you don't put a start command up at the top and an end command at the bottom, I'm just following that because it's slightly formatted. It is one mechanism for describing these things. I could describe them, you know, in more English type terms. All right, then a miracle occurs. We need to figure out how to convert kilometers to furlongs. So here's what I'm betting would be easy to do. And yeah, I could probably look up an exact conversion. But I want to find out how many yards are in a furlong. And then I want to find out how many yards are in a kilometer. And I can use that information to go from kilometers to furlong. And I'm not going to show y'all, you know, manipulating the formula for doing that and balancing equations or whatever. But I'm going to go ahead and go and get that information. And maybe you'll see how I do it. But you can always ask me for a formula if I ask you to do something and the formula is not there. Fine. Don't get any smaller. I don't care. All right. So 1 furlong in yards. That's what I'm Googling up, and it's telling me that 1 furlong is equal to 220 yards. Okay. Now I'm going to find out how many yards there are in a kilometer. So I'm going to come back up here and type 1 kilometer in yards. All right. There's that many yards in a kilometer. 1 kilometer equals that many yards. I can use that information to calculate furlongs from kilometers. And I'm just going to go ahead and write the equation without doing, you know, the step by step. So what we're going to say is furlongs equals the number of yards divided by 220. Nope, sorry. It's the number of kilometers times 1093.61, whatever, divided by 220. That is the equation for calculating the number of furlongs from the number of kilometers. And if you felt like being, you know, a math or a chemistry student and balancing that yourself, that'd be totally fine. If you feel like asking me for it, that'd be fine. If you want to come up here and type in 1 furlong in kilometers and see if it'll give you an answer, yeah, what do you know? I could have done it in 1 step just by doing that. Okay, so that's our equation. That's the then a miracle occurs part. So I'm going to replace then a miracle occurs with furlongs equals kilometers times 1093.61 divided by 220. So maybe I gave you this equation up in the problem specification, right? I may have said, you know, hint, like that. Or maybe I just asked you to ask me or look it up yourself. This is no longer useful information. I just used it to derive that equation. All right. This is an algorithm. Output that, input that, perform the calculations. Some people would like to put the word set in front of it. Some people, books show stupid things like doing that. Whatever. I'm not going to make this overly fussy. I'm just going to make it look like that. Now, this is not programming code. This is pseudocode. Pseudocode is a description of an algorithm. Are you going to write pseudocode? Nah, you don't have to, but you could do the same thing, right? Ask the user for kilometers, calculate furlongs by this equation, right? And then output furlongs, right? At least it gets the structure in your head, right? This is just as useful as this. All right. We could actually program that. That might be funsies to program. Your idea of fun might be different than mine. Let's go ahead and open up idle. All right, never type any code into the arrow thing. I think I've told you that before, and then in my last class I had 2 different people type in like 20 lines of code in it and lose it all because they typed it there. Always do file, new file. Then pick where you're going to save it. Save as, and if I am correct, this is Lecture B. So I'm going to come in here. Well, great, I named that one Jan 22. I'm going to give this one the name Lecture B. How's that for consistency? All right, here we go. I've saved it. I'm going to describe what this is. My name is Jeff Thompson. Your name is something different, so don't put that. Then CIT1203 Lecture B, convert kilometers to furlongs. There just happens to be some, 1700s night, and we told them a certain number of kilometers, and he needs to know how many furlongs to walk. Okay, we have some pseudocode we can follow. If you're looking at pseudocode, the word start is effectively just a comment. You can leave it out completely. You don't even have to put it in your code. You start from that. Output how many kilometers and input kilometers. What's the function we're going to call to do our output? Yeah, we're going to use print. So print. How many kilometers, or km if we felt like shortening it. I'm going to put a couple spaces after it so it'll look pretty when it asks for it. And then km is equal to input, and then I'm going to do the conversion. I'm sorry, I did not read that out entirely. Km is equal to input, parentheses, close parentheses. Don't need the space there. And then km is equal to float. Km. You feel like doing all this in one line? You absolutely can. Here's what it would look like if it was all in one line. I'm going to put it as a comment, but it would do it. Km is equal to the float of the input, and here's our input string. How many kilometers? That would do in one line what that does in 3. You like that better? Then comment those out and put that in, right? Let's just test it and make sure that that's not a syntax error. How many kilometers? Okay, not a syntax error. It works. So what this is doing is we have a function called input. And when it's invoked, it sits there and waits for the person at the keyboard to type something and hit enter. And as soon as they hit enter, everything that they've typed in the keyboard gets stored in that variable as a string, as a series of letters. And if they typed in periods and numbers and whatever, that's a string. Since we have a string, we have to turn it into a number. Why not turn it into a floating point number? Because if they typed in 3.1 and we tried to convert it to an int, it would throw an error because 3.1 is not an int. Float's more flexible because it accepts decimal points if you put them in, so that's why I did that. So this displays that, gets the input, converts it to a float, and stores it there. That's exactly what these 3 steps do as well. Alrighty, we have the number of kilometers. Go ahead and run it, guys, and if anybody's got a syntax error at this part, let's go ahead and fix that before we go on. Alrighty. One thing you'll see in the textbook is the use of backslashes to break things across lines. Like, what if I got to here and I realized that was going off the screen? I could put a backslash, which is the one above the enter key, and do that. I don't tend to do that, but the book has examples that do that. And I guess if I really, really wanted to keep this window filling only half the screen all the time, I might be more aggressive about using the backslash. That just means go to the next line. All right, then next, that equation. Furlongs is equal to that times that divided by that. I'm going to pad this out a little bit. Furlongs equals Km times 1093.61 divided by 220.
Is it IKM?
It is not. Where did I get that I from? Km. Furlongs is, yeah, thank you. Furlongs is equal to Km, kilometers, because that's what they typed in. Very good catch. Times that number divided by that.
You not put KM and 1093 in parentheses?
Did I make a mistake? Pardon?
You not put that in parentheses first?
I don't need any parentheses in this equation. I certainly could. I could put that in parentheses,
Mr. Thompson?
or I could put the whole thing in parentheses. Just a second. But there's no part of this expression that relies on parentheses. Unlike if it was like this, a is equal to 1 plus x divided by 3, and we had to put parentheses there to get it to work. If I'm understanding your question correctly, no, there's no part of the, no. So yes, ma'am.
She can't get her.
Okay, let me come back there. No problem.
She does.
I'm going to kind of write this in a language known as C++. If I was going to get this to work, I would have to declare my variables first. Something like float, kilometers, float furlongs, and then I could get some data in them. That just happens to be the output statement. How many km, right? I'm not going to take the time to make this really look good. And then CIN, that's the equivalent input statement in that language. And then you would do your calculation. Furlongs is equal to whatever. Right, whatever. I don't know. And then we would write out our answer. Right, like that. In those languages, if you do not declare your variable beforehand, the language doesn't know what kind of data you can store in it. Now you could create the variable on the fly in this case. I could say float there rather than having to define it up here. But as long as I'm going ahead and creating variables, I may as well create a lot of them at the same place. This language does not require you to declare your variables before you use them, before you start assigning to them, I should say. So I did not have to declare kilometers before I assigned a value to it. And I did not have to declare furlongs before I assigned to it. Now, those other languages, once you declare a variable, that's the only kind of data you can put in it. If I went over here and I tried to say, kilometers is equal to Joe, that's going to be a syntax error because kilometers is dictated to be a numeric value, a floating point numeric value. This is impossible for the C language to handle. Not impossible in Python. Python doesn't care what the data type of the variable is. It'll happily erase it and create a new data type for it. So, if later on I feel like making, say, KM, don't type this, Mary had a little lamb, that's not a syntax error. It means I can't do math in it anymore. If I repeated this equation here, then that would blow up because you cannot divide Mary had by 220 and multiply it by 1093. Does that make sense? Okay. Yeah. For programmers who've used other languages, it looks weird not to define your languages ahead of time. Your variables ahead of time. All right. Now let's write it out. Not output. That was my pseudocode. Print parentheses, quote, parentheses, quote, that is, end quote, comma, furlongs, comma, beginning quote again, furlongs, period, end quote, like that. What that is doing is it's going to display this string, and then where there's a comma, it's going to add a space to the output, and it's going to display that number, and it's going to put another space where that comma is, and then it's going to display that last word. I could have made it shorter. I could have just said, don't type this. I could have just said furlongs equals, right, comma, furlongs. That would have been enough to get, the idea of what that equaled. I made it more English-like. Or if I was really lazy, I could have just did this, print furlongs. Then it would print a number and we had no idea what that was, right? So I'm going to leave it like this and I'm going to test it. I recommend y'all do that too. Run module. I did start the recorder again, did I not? Yay, alrighty. How many kilometers? 1 kilometer. That is 4.97 furlongs. Now I happen to know that 2.2 kilometers is about equal to a mile. Just out of pure curiosity, I'm going to run it again and type in 2.2 kilometers and see how many furlongs it is. About 11. There's probably some special relationship between the two. I don't know. You know, the English units of measurement are insane, right? Okay, so there we go. We have written a program based on an algorithm. We expressed our algorithm as pseudocode. I'm going to go ahead and copy. Now I'll just put this on at the end. The code for this is included later. All right, we're going to do one more problem like this. But let's not blow off the lecture tools completely. So algorithms can be represented by pseudocode, or they can be represented as code from a programming language. That's what we're going to be doing the vast majority of the time, right? I could give you pseudocode and ask you to convert it to a programming language, but usually I'm just going to describe a problem. And you have to think of how to solve it however you want. Write down the steps first, or if you think you can just sit down and start typing without having written a single thing down, more power to you. But if you get confused and you ask for help, I may ask to see, the logic for your program. And if you go, I don't have any, then I may ask you to write it down. I'm not going to be a jerk about it, but you have to think these things through. Good point. Underneath everything, the only thing that a computer can hold is numbers. And ultimately, those numbers are stored as 0 and 1s in the memory and the hard drive and stuff like that. Since I know you're going to read all this, I don't mind skipping it. All right, this is a good point. The difference between a compiled and an interpreted program. A compiler is something that takes source code, like the stuff that we just typed, and turns it into machine language, which is then saved to a file, like a .exe file. That's what a compiler does. And then the user runs the .exe. So you can mail them the executable. You can upload the executable to an app store, whatever. Once the user gets it, they can run it. Probably have to run an installer and all that, but that's the way it works. An interpreter is a little bit different. Interpreter starts with the source code, and then the user runs it, and then at that point, it is turned into machine language. A little bit different, little different order, right? That means that every time the program is run, it has to do that conversion again. And that conversion takes some time, right? Here, it didn't matter how long it took. It could take 2 days to make that executable. The user doesn't care. They just get the executable, right? Here they do care how long it takes, right? Fortunately, this conversion is pretty fast. I should put the word interpreter in between those two things, because when you run it, it sends the source code to the interpreter, which then gets converted into machine language. So this is the way that Python works. We type in a program, we click run, and then the Python interpreter, kind of like that shell we've been seeing every time we load up Python, loads up, takes every line of code in our source file and runs it line by line. That interpreter does take some time, which is why you would not, well, it's one reason, why you wouldn't write like Call of Duty or some PlayStation 4 or Xbox game in Python. You would write it in a much faster language. You would write it in a compiled language, like C++. So an example of a compiled language is C++. And then an example of an interpreted language is Python. Now colloquially, when we run it, like if I go here and I run my program and it says run module, I might say it compiled it, but it didn't compile it. It interpreted it. It does a sanity check when you run it to make sure that the syntax isn't horrible, as much as it can, but then it starts actually running it. An interpreter is like the idea of an emulator for y'all guys, girls who like playing old video games on your modern computers. You want to play your Nintendo or your Genesis games or whatever, then you can load an emulator on your computer, and as long as you can find a file that represents the data from a cartridge, then that emulator can load that file and it emulates all the hardware, right? It emulates the display so that you can see what it's doing, and it emulates typing on the keyboard and turns it into, you know, whatever that program was expecting from a joypad. That same stuff that you downloaded from the cartridge, a binary file, can run on any machine that has an emulator written for it. So, you have Genesis emulators that run on Macs, on PCs, on Raspberry Pis, whatever. You know, the same set of zeros and ones works on all of those. Python's the same way. So it's not really an emulator. It's not emulating hardware, but it is handling a language and producing the results. The results will vary on a machine-by-machine basis. Well, the way you control a machine varies on a it's writing a program that runs on a Mac is very different than writing a program that runs on a PC, unless you have an interpreted language and the interpreter is doing all the heavy lifting of converting stuff so that it all looks the same no matter which machine you're running it on. Well, I hope that kind of makes sense. Otherwise, just remember that it's an interpreted language and answer the quiz question or whatever. I think I misspelled that. I'm going to take that out because the interpreter actually kicks in here, right? Takes the source code, it runs it on the fly. Each line is turned into machine language so that it can execute on your computer. And that's what this is showing. Use a text editor, create a PY file, you run it through the translator. If there are syntax errors, then it stops. It doesn't produce anything. You know, it doesn't go on from there. If there weren't any syntax errors, it goes to the so-called runtime system, the Python shell. If there are other error messages, the Python shell would display them. The Python shell would sit there and let the user type in whenever input was called, and the Python shell would display the output. Yeah, enjoy that slide, guys. Let's look at it. No, let's not. The history of computing systems. Read it in the book. It's interesting stuff. The fact that in my fundamentals class, I tend to talk, you know, a lot about these kind of things. But we meet once a week, and it's in the book, so I don't need to talk as much about it. You can see why. Alrighty, we're getting there. Alright, so Python is a high-level, general-purpose programming language for solving problems on modern computer systems. Invented by Guido van Rossum, who was a big fan of Monty Python's Flying Circus. It's circus. Python is an interpreted language. Simple Python expressions and statements can run in the shell. We could pop open the shell and we could type in simple commands. Easiest way to open the shell is to launch idle, and then to quit, you close the Windows close box. The shell is useful for experimenting with short commands. Like that. Pops open the shell, we could type stuff in at the arrow prompt. So programs usually accept inputs from a source. That source could be from a file, right? Or maybe you have a key card reader or something like that, and somebody passes a card through it, and it gets its input that way. Or it's got a touch screen, whatever. And then it processes that and it outputs the results. So in a terminal-based interactive program, which is what we are writing so far, console application, same thing, terminal, console. You type in with the keyboard, and then it displays in a terminal window. Terminal sounds so old school, like 60s and 70s, but that's what we call this right here. Although most people call it a console rather than a terminal. Still, that's a window, right? And that's where the output and the input are going to happen. So, programmers can force output of a value by using the print function. Print expression, I like that, force, right? Force. Okay, yeah, we're directing it to do it. Whenever you see an example in this text and it shows something like that, you don't use the angle braces. The angle braces kind of are a fill in the blank, right? They could have just as easily done that. And then whatever you're supposed to put in there. You don't use the angle braces at that particular point. And they give an example down here. They want to print high there, then that went between the parentheses. If I copy that code and paste it into the shell, is it going to work? It is not going to work. Show you why. Python doesn't know what to do with tilted quotes and apostrophes like the Office applications generate. So when I run this, it's not going to work. If I wanted it to work, I would have to go in and replace those with real quotes. Which means that there may be plenty of times when we're looking at the PowerPoint and wish we could copy and paste code. And it might not work. We might have to make that change. So the input function builds a string from the user's keystrokes. So the strings that represent a number must be converted from that string to an appropriate numeric type. Right? You can't do data, you can't do multiplication if it looks like that. It has to be turned into a number, and that's why we use the float function. We can also turn it into an integer by using the int function. String data must be converted to a numeric form with the float function or the int function if you happen to like whole numbers. I tend to avoid the int function unless I absolutely need a whole number, because if the user types in 1.0 meaning 1, then the int function chokes on it. It sees that decimal and it doesn't think, oh, well, it was just 0.0, so I can drop it. Instead, it crashes. So I tend to always use float, unless I have a real good reason otherwise. That's why all of my examples are probably going to say float, or at least the vast majority of them. So the float function takes a string of digits and turns it into a floating point number that can be stored in a variable. The int function takes a string of digits and turns it into a variable, an integer variable. The int function can also take a floating point number and convert it into an integer. It'll just round down. I'll give you an example of that. It's actually used the shell for something. So if I do this, x equals integer 3.14159, x equals 3. If I do x is equal to the integer version of 3.9, it's still 3. It rounded down. That's what the integer function always does. If you want to round a number, rather than have it rounded down, there is a round function. I would just mention this, not part of this stuff right here. So if I crank up the shell again, and I do x is equal to round 3.9, x is equal to 4. X is equal to round 3.14, x is 3. So the round function is a nice function if it's okay to round it up or round it down. Probably more often we want to do that than just lose everything, right? It depends on whether rounding is appropriate or not. And if you can do your math without any rounding at all, if you can do floating point numbers, that's best, right? So I'm really not going to be using round much, and I'm really not going to be using INT much. About the only time I might want to round is if I want to make the display pretty. And what do I mean by that? If I have x is equal to 1/3, that's pretty nasty. But what if I want to round it down so it looks pretty? X is equal to the rounded version of x, and I want it rounded to 2 decimal points. Now it just says 0.33, right? Again, we'll cover that again. I'm not expecting you to memorize every single thing that I'm typing at this point. Although I could cut and paste this into our notes. No, I can't. There it goes. All of these functions are color-coded in our editor. It's just to let you know. If you type in something and it's not purple and you expected it to be, it's because we did something wrong. I made that an uppercase P, right? There are other colors that are used as well. Obviously, we see black. Black is used for what are known as identifiers, which are variables and function names, and also for numeric values like that. And then we've seen green. Green is for strings, red is for comments. There's also orange. We don't see any orange, but the orange ones are the keywords. The keywords are things like if, and else, and or, and while, that kind of stuff. So if furlongs is greater than 1,000, print, that's a lot of furlongs, eh? Okay. Else, print, that's not so many. Now, is this stupid? Yeah. But it's just showing you the keywords. There's only about 20, 25 Python keywords, and we will learn the majority of them by the time we're done. Notice that every time you have a colon, we tab after that. Another way to put it is every time you tab, there better be a colon in the line in front of it. If I mess up my tabs, it messes up. Like, don't do this, but if I put a tab there, a lot of programming languages would think that was totally cool. Hey, no problem. Python won't run that. It'll complain about the indentation. Let's do one more algorithm, and let's see how far we have left. We're almost at the end of this stuff. So, editing, saving, and running a script. We can use Python, we can use idle to create a py file. And then once we've written that script, we hit the run menu, or you hit F5 if that works for you. Python programs that use the py extension. Talked about this. Python goes into the syntax checker, and then the translator, and then what it generates, it's not exactly machine code, but it's close, then gets run by the so-called Python virtual machine, kind of like the emulator I talked about. So whatever this produces, a translator runs into this, which does this display on the screen and accepts input and stuff like that. Programmers often, or inevitably, make typographical errors. You may misspell your variable names, you may put caps where you're not supposed to, you may put tabs, you'll mess the syntax up. Python interpreter will usually detect these. So the syntax are the rules for forming sentences in a language. I think that's kind of silly to call it sentences, but syntax is the grammar of the language. Tells you where to put the punctuation. If I have to express that, the syntax says that the equal sign has to follow the variable name. and I think I've given this example before. This is a syntax error because equal sign has to be followed by one thing, and that one thing has to be something that will store the results of this expression. Another syntax is that if you have an opening parentheses, you better have a closed one. You have to have matching parentheses, right? If you have an opening quote, you better have a closing quote. You better not have two closing quotes, right? So it's just like that. If I'm going to write a function, there's going to be a def keyword, and it's going to be followed by some parentheses, maybe with something between them, and then a colon. And if I'm missing any of that stuff, it won't be a function. And then after that, the next line of code, and all the other lines that are supposed to be in that function need to be indented. And if they're not, it won't work. If I left the colon off, it will not work, right? It's not to mean that it's all super picky. There are other languages with far more strict syntaxes than Python. But it is the grammar of the language. It tells us the order in which the pieces need to be written and how they are formatted with the special symbols of punctuation. And if Python encounters a syntax error, it halts the execution of it. Unless you, we'll just leave it like that. All right, and then the summary. Some real computers are specialized for a small set of tasks, whereas a desktop or laptop computer is a general purpose problem-solving machine. And so are our phones nowadays, right? My phone is probably more powerful than my desktop computer, just because my desktop computer is still running Windows 7 and it's pretty old. But you can have a computer in your microwave, right? All it needs to do is control, pieces of the microwave. You can have a computer in your, fridges are weird nowadays. Fridges with, touch screens and stuff like that. And cars have all sorts of computers inside them, right, working in conjunction to get, they're scary. Anyways, so Python is a high-level function. I'm going to let you read the rest of this review yourself. I strongly recommend you always read the PowerPoints, even if you're not going to dip seriously into the book. But you are going to dip into the book when you're doing the quizzes. All right, one more algorithm, because it's going to lead up to your homework. Here's what I want the homework to do. I'm going to get rid of that. Algorithm for calculating area of a rectangle. Now somebody tell me how you calculate the area of a rectangle.
Length times width.
Yeah, length times width. So that's what we're going to do. We're going to ask the user for length. We're going to ask the user for width. We're going to say the area equals length times width. And then we're going to output the area. I'm going to replace these words ask the user for with input. Input length, input width. Now we have seen that in our program that when the pseudocode said input, what we really do is use a print function and then an input function and then a float function. We have to do all three of those things for our input. Now I could express this in a more strict pseudocode, but we get it, right? We get that these are the four essential steps we're going to do. But in order to do an input, we have to do all three of these things. Yeah, let's get to it. If we had all the time in the world, I'd ask you to do it yourself. But that's what's going to be for the homework. So let's just print a message, which is going to be a bunch of stars. Tell us that we're in a whole new section of the program, just to be pretty. Okay, now print, parentheses, quote, what is the length of the rect? I'm going to expand this. Angle, question mark. If you just want to say length equals question mark or something like that, I don't care. Now I'm going to get my input. Remember how I said you can do it in one step or you could do it in 3 steps? I'm doing it in the 3-step method here, but I could do it in that one step too. So L, or how about the whole word? length equals input, parentheses, end parentheses. Now I'm going to convert that to a float. Length equals float length. And I hope it makes sense to you that you could do it that way or you could do it that way. And it absolutely does not matter which way you do it. There's only one side effect of doing it this way, is that if you do it this way, it goes to the next line before you can type it in. And if you do it this way, then it stays on the same line where you can type it in. That's the only functional difference. All right. We've gotten the length of the rectangle. Let's get the width. Print, parentheses, quote. I could have just cut and pasted. Copy. What is the width of the rectangle? Parentheses, end quote. End, excuse me, question mark, end quote, parentheses. Now let's get my input. Width equals input. And you don't have to do the spaces. I just try to do that to make it easier for the people in the back. And then lastly, we have to convert width to a float. Width equals float width. Quite often people bring me their code and they're missing this part. They'll just say width equals float. That's not going to go. Or they have that. Or this is the most common one. They have, get back down here, this. That was supposed to convert width to a float. It did. It did convert width to a float, but it didn't store it anywhere. So the original variable was unchanged. And it's not because you're dumb if you do that. It's just because you're not familiar with the syntax yet. Alrighty, let's calculate the area. Area equals length times width. And then lastly, we're going to display it. Print, parentheses, quote, the area of the rectangle, or we could just say the area, is, end quote, comma, area. Now I hope you get that this is just for display. It doesn't matter. We could type this in all caps. It's just part of the string that's displayed. We could write this in Spanish, you know, go into Google Language Tools. And I want to do the area is, and I want to translate that to Italian. And there we go. Okay, so there we go. Right, I'm displaying that the area. Right, it could be anything. Right, whatever's in the string is for displaying to the user. It does not affect the calculation. Let's see if I've managed to type this in without any typos. Run module. How many kilometers? I don't know. 10,000. It displayed a bunch of stuff. I can't make heads or tails out of what I'm seeing, so I'm going to close the shell and run it again. All right, how many kilometers? 1,000. That's a lot of furlongs. What is the length of the rectangle? It's going to be a 2 by 3 rectangle. 2, 3. And the area is 6. I'm convinced. That looks like it worked to me. If we give it any bad data, it's going to crash. Bad data being defined as non-numeric, or something like with 2 decimal points, 5.55.5, right? And boom, it blows up. We could make it handle that. This is not a syntax error. This is a runtime error. Right, there's no way when the code was being compiled that it could think in advance, well, that stupid user is going to type in the wrong data. It had to wait until runtime to figure that out. So these are our variables. Variables hold pieces of data. The variables can be strings, which are sequences of stuff typed in from the keyboard, or names or whatever. They can hold numeric values. This is what's known as an expression. An expression is, you know, one or more variables and the mathematical symbols. Actually, an expression can just be something like, this is a simplest expression, x equals 1. That's also an expression, but it's almost so simple that you wouldn't call it an expression. When you say x is equal to y divided by 2, now that's an expression, right? Now we're talking. whatever. We can type one as long as we want. So there's one more type of math that I want to mention, two more types actually, which are exponents and something called floor division, because we're going to use these in our homework. Sound complicated, but they're not. So I'm going to go back to the shell, run this, and I'm just going to print out. No, I'm not going to run it. I meant to launch the shell. Python shell. Okay. Now here's what I'm going to do. If you have x equals 1 times 2, we know what x is. X equals 1 plus 2, we know what that is. X equals 1 divided by 2, x. X equals, subtract it, 1 minus 2. No surprises. X equals 2 star star, or how about 3 star star 2? That means to the power of. That means 3 squared. So when I print it out, what is 3 squared? It's 9. So star star is power of. So along with these symbols, add, subtract, divide, and multiply. We also have star star, which means to the power of. Example, 3 to the power of 2. And then there's another one, which is slash slash. That means floor division. Floor division means do the division and then round to the next lowest number, next whole number. Like this. What is 5 divided by 2? 2.5. What is 5 slash slash 2? Well, that means divide 5 by 2 and then round down. Does that make sense, guys? Yes, sir.
Is there modulus division in
I'm sorry, pardon me?
there? Is there modulus division?
Yes, there is modulus, and I should mention it. I'm not going to this time. Okay, why not? Why not mention it? All right, modulus means remainder. When I divided 2 evenly into 5, I got 2, but then there was a remainder. What was the remainder? And don't say 0.5, it was 1. Right, and so modulus is the percent sign. 5 modulus 2 is 1. I'm going to mention that a little bit more. Then I'm going to create our Dropbox and stuff like that. Talk about the homework. So, 5 divided by 2 is 2.5. 5 floor division is 2. And I like languages that have floor division and star star, but C++ and Java do not have those. And then 5 modulus 2 is 1. Well, what is 6 modulus 2? 6 divided by 2 is what? It's 3. Is there a remainder after that happens? So, the remainder is 0. We'll talk about modulus again. Let's go look at the homework, and then I'll make a Dropbox and answer questions. Don't have to be at the next class for 15 minutes or so, but I want to make sure that we have time for questions and for talking about the homework. Did everybody get that running who wanted to get it running, or were the people getting syntax errors? All right, if you did get syntax errors, I guess at this point I'd ask for you to wait until after I create the Dropbox. I don't know why I have 3 separate homework folders. We're going to get rid of some of them real fast. So homework 1, input in math. And of course I'll make a Dropbox for it as well. Write a program that will ask the user for two numbers, x and y, just like we asked for length and width, right? Print the result of x multiplied by y, print the result of x added to y, of x divided by y, of x floor divided by y, and x to the power of y. Oops, I forgot the y there. And if you feel like adding on a 7, which is a modulus, x modulus y, feel free. And then down here is a reminder. To do floor division, you use 2 slashes. To use power of, you use 2 stars. Does that make sense? What you did today sets you up for this homework, right? You could just print out your homework or take a screenshot of it. I mean your in-class work where we asked for length and then we did a calculation and we printed it out. The only difference here is we're going to be doing 6 calculations rather than 1. That's okay, you can do that. Right? If you had to do it, you might store the results in 6 different variables. A equals x times y. B equals x plus y. C equals x divided by y. Right? Or you could reuse a variable name by doing the calculation and then printing the result. Then doing the calculation and then printing the result. Then doing the calculation and printing the result. If you get stuck, ask me for help. We'll come by the office, but we could probably hammer this out pretty quickly by texting if you ask me. I bet it would take like no more than 2 texts. So, if this makes sense, I'm going to make the Dropbox. Are we all pretty comfortable with it? I see some people not nodding, but you're not shaking your head no either. Alrighty.